Okay, we are moving right along to Chapter 6. Chapter 6 discusses the factoring of polynomials. We have already learned how to multiply polynomials, divide polynomials, and we've talked about some special products when we are multiplying polynomials. Well, those special products and those concepts that we talked about in Chapter 5 are crucial to understanding what's going on in Chapter 6. The first thing we talk about is the greatest common factor and how to factor by grouping. Well, actually, it's the beginning. It's like a preview of factoring by grouping that we discuss here. Let's look at what the greatest common factor is and how we find it. Finding the GCF of a list of integers. Write each number as a product of prime numbers. Number 2, identify the common prime factors. Number 3, the product of all common prime factors found in step 2 is the greatest common factor. If there are no common prime factors, the greatest common factor is 1. Now, what is this saying? Basically, when you look for the GCF, you're looking for the greatest number that can be divided evenly into two numbers that are given to you, 2 or 3 or more numbers. You're looking for the biggest number that's a factor of those numbers. And one of the easy ways to find this biggest number, other than just guessing, trial and error, is to find what we call the prime factorization. Factor these numbers into their prime factors. So what are prime numbers? Remember, prime numbers are whole numbers other than 1 whose only factors are 1 in itself. So your prime numbers are numbers like 2, the list of primes is the set, that includes 2, 3, 5, 7, 11, 13, 17, 19, 23, and so forth in that pattern. Actually, there is no pattern for prime numbers. So the thing is, we have to kind of know what numbers are prime, and at least the first several, you should know that 2 is prime, 3 is prime, 5, 7, 11, 13. And what that's saying is that they don't have any other way of multiplying to get those numbers other than 1 in itself. In other words, 2. If you look at 2, there's no other 2 numbers you can multiply together to get 2 other than 2 and 1. No whole numbers. Now remember, we're talking whole numbers. There's no other way to get 3 other than 3 times 1, or 1 times 3. There's no other way to multiply to get 5 other than 5 times 1. 7. 7 times 1. 11. Notice the numbers that are not there. 4 is not prime because there's more than one way to get 4. 4 times 1 is 4, but also 2 times 2 is 4. So prime numbers are numbers that can only have 2 factors, itself and 1. And in order to facilitate finding the GCF, you must learn how to write the prime factorization of a number. For instance, look at 45 and 75. When I say write the following as a product of primes, that means you use whatever method you know how. Some of you learned how to use a factor tree. Some learned how to do some other kind of way. You factor 45 into its prime factors. In other words, I'm going to start with the smallest prime number that I know divides into 45. The smallest prime number that divides into 45 evenly is 3. Now 3 times what is 45? 3 times what is 45? 3 times 15, right? So I know I have 3 times 15, but I'm going to break up 15 before I write it down. I'm going to break 15 up into prime numbers. Now, what are the prime factors of 15? 3 times 5. And as long as I end up with a prime number, I know I'm finished. When all of my numbers in this factorization here are prime, then I know I have finished writing the prime factorization. The thing is, we do write it in the exponential form, so we'll write 3 squared times 5. Well, isn't that 45? 3 squared is 9, and 9 times 5 is 45. But the prime factors are 3 times 3 times 5. Now do the same thing for 75. Okay, think of the smallest prime number, which divides into 75. Well, that's 3. 3 times what is 75? Think of 3/4. So 3 times 25. But is 25 prime? No, 25 can be broken up into 5 times 5. Okay? But 5 times 5 can be written as 5 to the second power. So once we found the prime factorization now, which is what the instructions up here are saying, it says write the following as a product of primes. We did that. But now look at the product of primes. Look at the product of primes. One of them has 3 squared times 5. The other one has 3 times 5 squared. Now what do they have in common? In common, greatest common. They both have a 3. They both have a 5. They don't have anything else in common. Okay? But they have 3 times 5, which is 15. So the GCF for those two numbers is going to be 15. Now, if you know another way to work it out to find the GCF, please have at it. But those of you who don't, you need to follow this process. Let's do a few more. I want to first write the prime factorization of 36 and 42. And then we're going to look for the GCF. Well, 36 can be written as the smallest prime that divides into 36 is 2. 2 times what is 36? 2 times 18? But 18 is 2 times what? 9. But 9 is 3 times 3. Right? And then so ultimately that's going to give us 36, which can be written 2 squared times 3 squared. What about 42? 42, if I want to write it as a product of primes, 2 goes into 42 21 times. But 21 can be written as a product of prime numbers as 3 times 7. Okay, so this can't be written any more simplified than this. 2 times 3 times 7. Now, what do they have in common? The GCF of 36 and 42 is what? The biggest thing they have in common is this one has a 2, but the other one has 2 2s, but I can only choose one of them because that's all they have in common. Notice, I'll erase this. It might be easier to see over here. They have the 2 in common here and one of the 3's in common. That's all they have in common. So what's 2 times 3? That's going to be 6. Okay? So it comes from 2 times 3. So the GCF for 36 and 42 is 6. Now what about 32? Let's break up 32 and 33 into prime factors. 32. equals 2 times 16. But 16 is 2 times 8. But 8 is 2 times 2. If you multiply this out, it will give you 32, which is 2 to the 5th. 33 is 3 times 11. Okay? Well, notice the two numbers, 32 and 33, don't have a factor that we can visibly see that is common to both of them. But keep in mind that they do have this 1. You remember, anything can be times 1 and not change its value. So ultimately, whenever it looks like two numbers or three numbers don't have a GCF, when it looks like they don't have a GCF, then you can't say they don't have one. You have to say the GCF is 1. Okay? Now let's do 14, 24, and 60. 14 can be written as a product of prime numbers as 2 times 7. 24 can be written as 2 times 12, but 12 is 2 times 6, but 6 is 2 times 3. That's 24. 60 can be written as 2 times 30. Let's see, and 30 is 2 times 15, but 15 is 3 times 5. All right, so we have 2 times 7, 2 squared times, 2 to the 3rd times 3. And 2 squared times 3 times 5. Now we're looking for the greatest common factor, so it has to appear in all of them. So what's the greatest common? Well, if you notice, 14 has a 2 to the 1st power. 24 has a 2 to the 3rd power. 60 has 2 to the 2nd power. Well, the greatest number that's common to all of them is just the plain old 2. They don't all have a 2 to the 3rd or 2 to the 2nd, but they all do have a 2 to the 1st. Do they all have a factor of 3? Well, 60 has a factor of 3 and 24 has a factor of 3, but 14 doesn't. They don't all have a factor of 5. Look at it. They don't all have a factor of 5. They don't all have a factor of 7. So the GCF for these three numbers is 2. Okay? Right quick, let's think. Sometimes you can look at them and tell what the GCF is going to be. We're looking for the biggest number that will divide now into 12, 16, and 40. I'm thinking it's going to be 4, but let's see. Let's write 12 as a product of primes. That's 2 times 2 times 3. 16, 2 times 2, that's 2 times 2. 40 is 2 times 2 times 2 times 5. So we have GCF is going to be what? We have, each one of them has 2 factors of 2. They don't have anything else in common. But what's 2 times 2? 4, which is what I initially said. Sometimes you can look at it and tell. 15, 18, and 66. What do you think it's going to be, the GCF? I'm thinking it might be 3, but let's see. 15 equals 3 times 5. That's prime numbers. 18 equals 2 times 9, but 9 is 3 times 3. 66 is 2 times 33, but 33 is 3 times 11. So the only thing these numbers have in common is a 3. So therefore the GCF is 3. You have to know how to do this because we're going to be doing something called factoring out the GCF in a minute. Now let's look at finding the GCF of a list of terms. Now let's quickly look at what x squared, if you're given a list x squared, x to the third, and x to the fifth. What does x squared mean? It means x times x. X to the third means x times x times x. X to the fifth means this. Now, look at those terms and tell me what's common to all of them. What do they all have in common? How many factors of x do they all have in common? Look at it. They all have at least 2. So the 2 factors of x is what they have in common. So the GCF is x times x, which is x squared. Now notice where the x squared comes from, okay? And you don't have to go through all of this, what I just showed you. All you have to do is look at the list of terms that you're given. Look at x squared, x to the third, and x to the fifth. And look at the one that has the smallest exponent. So when you're looking at terms like this, variable terms with exponents, the GCF is going to be the one that has the smallest exponent. Okay, you don't have to go through this whole illustration that I went through. So when you have y to the fourth in the next example, y to the fourth, y to the fifth, and y to the eighth, you should be able to just look at it and say, well, the GCF is going to be y to the fourth. Because inside of y to the fifth, there is a y to the fourth. Inside of a y to the eighth, there's a y to the fourth there as a factor. So you don't have to go through everything that I went through in order to figure it out. So between x and x to the 10th, the GCF is going to be what? Which one has the smaller exponent? Just x. Okay, so remember that the GCF of a list of terms contains the smallest exponent on each common variable. That's what I just finished saying. Now, let's look at finding the GCF of a list of terms here. We have 5y to the fourth, 15y squared, and negative 20y to the third. Okay, let's first look at the 5, the 15, and negative 20. Well, we're not going to worry about the negative sign right now because they don't all have a negative. We don't want to worry about the GCF containing a negative number right now. But look at 5, 15, and 20. You should easily be able to see that the GCF for that part is going to be, for the numerical part, is going to be 5. But for the variable part, we have y to the fourth, y squared, and y to the third. So which y would it be? Y to the what? The smallest exponent is y to the second. Okay, they all have at least y squared. Okay, so that's the GCF. Okay, now look at the next one. We have 4x squared, x to the third, and 3x to the eighth. Well, they don't all have a numerical factor in common. You have a 4 as a numerical coefficient, a 1 as a numerical coefficient, and a 3. Well, all they have in common in that respect is a 1. But we don't write 1 as a coefficient. So let's forget about the 1 and just figure out what exponent we should put on our x. So x to the what is the GCF? X squared. Okay. What about this one? a to the fourth, b squared, a to the third, b to the fifth, and a to the second, a squared, b to the third. Well, GCF. I'm looking for the a with the smallest exponent. It's going to be a squared. The b with the smallest exponent is b what? Squared. That's what's common to each one of those terms. Now we're going to take it up a step and we're going to do what we call factor out the GCF. Factor out the GCF. So basically we're dividing it out. We're going to figure out what the GCF is for the terms in the expression and factor it out. So for instance, let's look at 8x plus 14. Look at the two terms. It's an expression now. But look at the two terms, 8x and 14. What is the GCF for the two terms, for 8x and 14? Look at 8x and 14 and figure out what's the GCF. Well, the GCF for those two is 2. 2 is the biggest number that will divide into 8x and 14. But once we factor out the 2, what do we have left? See, what you have to understand is once you say, well, I want to divide it by 2, I'm taking out a 2, which really means I'm dividing it by 2. I'm dividing out a 2. Okay? We don't go through this step what I just wrote there in blue. You don't do that on paper, but it's kind of like what you do in your mind. You're saying I'm dividing 8x by 2, and what do I have left? 4x. I'm dividing 14 by 2, and what do I have left? 7. Okay, so although we don't write these divide by 2 and divide by 2, we understand that that's what we're doing with the 2. Okay, so I'm gonna leave those divide by 2 there so you can refer to it, but we're not gonna do it anymore. Okay, now, so how do you know you have it right? Well, you have it right because you know that if you distribute the 2 times 4x is 8x, and 2 times 7 is 14. So you're right back where you started from. Okay, so what we're doing now is the opposite kind of distributing. We're undistributing, if you will. So look at 6t plus 18. The GCF for 6t and 18 is 6. And what do you have after you divide out a 6? In other words, if you divide 6t by 6, all you're left with is t. If you divide 18 by 6, you are left with a 3. And doesn't that multiply? If you distribute, we get 6t plus 18. So now we're factoring out the GCF. I'm not just asking you what the GCF is. Out. Let's factor it out. A 49x minus 35. What's common? What's the GCF for 49x and 35? 7. When you factor it out, what are you left with? 7x minus 5. All right, look at this one. Z to the third minus z squared. What's common to both of them? Remember, we're looking for the z with the smallest exponent. So z squared is common. But when you factor out a z squared, what are you left with this first term here? If you divide z to the third by z squared, what are you left with? Z. And if you divide z squared by z squared, now imagine z squared over z squared. Y'all gonna have to forgive the phone. People don't know I'm recording. They don't know. So let's factor out the z squared, and we're left with z. But what happens when you divide z squared by z squared? You get 1. This is very, very important that you understand that this is going to be a 1. Okay? You have to divide it out, but you have to place the -1 there. Because ultimately it has to work when you go back and distribute to check it. Z squared times Z is Z to the third. Z squared times -1 is minus Z to the Z squared. So you have to be very, very careful with that 1. Let's look at this one. We have a trinomial now. So let's look. -9 a to the 5th plus 18a squared minus 3a. Well, let's look at the numerical coefficients and try to see what the GCF is there. It is going to be 3. And what happens when you factor out a 3? Well, 9a to the 5th. Oh, my goodness. No, I'm not finished. How y'all let me do that? The numerical part is 3. But the a part is going to be what? What's common as it relates to the a's? It's just a. Okay, the smallest exponent on the a is a 1, so we keep the a. Then we divide it out. So 3a comes out, so that leaves us a -3a to the 4th for this term, plus we factor out a 3a here, we get 6a for this term. Okay, and I'm gonna go with what? If you factor out a 3a, then you're left with a 1. All right, so this thing goes back to here. Okay, now I'm gonna close the parentheses. Now check it by multiplying. If you multiply 3a times -3a to the 4th, you get -9a to the 5th. 3a times 6a is 18a squared. 3a times -1 is -3a. So we have just factored out the GCF. Do it again here. We have -12b cubed plus 10b squared minus 2b. Well, we can factor out a 2 and a b. And what it leaves us after we factor it out is -6b squared. Then divide 10b squared by 2b, you get 5b. Divide 2b by 2b, you get -1. Okay, and when you multiply it, you get, if you check it with the distributive property, you're going to get the original expression. Now please note that one thing you could have done, if you so chose to, is, you see this negative sign? If you wanted to, you could factor out a -2b. If you wanted to, if you just wanted, say, your first term to be positive, you could have factored out a -2b. And watch what I'm talking about. If I have a -12b to the 3rd plus 10b squared, same thing we just finished doing. Let's say we factor out a -2b. See how that's different from what we factored out before. But all it's going to do is change the sign of everything that we factored, that we have as our remaining expression. So all it's going to do is change the sign. Negative, where it was -6b, we're going to have a +6b squared. Where it was a positive 5b, we're going to have a negative 5b. Where it was a negative 1, we're going to have a positive 1, all because we factored out a negative 2b. Now, believe it or not, this answer and our original answer that we got in the first problem are both correct. Okay? But you have to recognize that they're both correct. So if you're working with someone and you both come up with two different answers, the thing is they're both right because they both multiply to the same thing. Okay? So sometimes you have that option, and there are going to be times when you want your first term, you want to factor out a negative. Okay? Sometimes you'll be told to do that. Other times it's going to be something that you have to know to do on your own. Now, from here on out, our steps are just going to say factor. So let's look at what we have here. We have a binomial that we have to factor. The very first step to factoring anything is to factor out the GCF. I cannot stress that enough. It was the first thing we learned how to do in this chapter. It's the first thing you do anytime you're factoring anything. You look for a GCF to see if you can factor something out. Sometimes you won't have a GCF, but you have to look for it. Okay, so look at 5x to the fourth minus 20x. What is the GCF? Well, the GCF is going to be 5x. That's what they have in common. And if you factor that out, you're going to be left with x to the third minus 4. Check it out and see that it multiplies out to be the right thing. 5x times x to the third is 5x to the fourth. 5x times negative 4 is negative 20x. Okay? Look at this one. Look at it and look for whatever is common. They all have a 9 in common. They all have an x in common. And they all have a y to the third. You're looking for the smallest exponent, remember? So y to the third. And what's left after you factor that out is going to be 2y squared plus the 9 comes out, the x comes out, so we have a y. And look at this, 9xy to the third and 9xy to the third, they're the same thing. So if I factor that out, it's just going to leave a 1. Check it out, multiply it to make sure that it multiplies correctly. Now look at this one down at the bottom with the fractions. So don't get apprehensive about it. Let's just look at it. We have 5/9 z to the fifth plus 1/9 z to the fourth minus 2/9 z to the third. But what they all have in common, I'm going to write it below. What they all have in common is 1/9 and a z to the, I don't like the way that z looks, 1/9 z to the third. But after you factor it out, what it actually does is takes that 9 out of the denominator of each one of those coefficients. So you no longer have the 9 down there. You no longer have a denominator because you basically factored it out. So now you're left with a 5z squared plus a 1z to the fourth, but I'm not going to write 1z. I'm sorry, 1z. 1z. I'm not going to write a 1z, but I'm going to write z because you have z to the fourth divided by z to the third leaves you just a z minus what? If I'm factoring out a 1/9, it's going to leave me a 2. But if I'm factoring out a z cubed, there's a z cubed up here. I'm taking that out. Okay? So the z cubed divided by z cubed is just 1. So it leaves us just with nothing but a 2. Don't believe me? Just multiply it. Multiply it out. 1/9 times this gives you 5/9 z to the 5th. 1/9 times this gives you 1/9 z to the 4th. 1/9 times this gives you 2/9 z to the 3rd. So we've done it. Let's factor out the GCF here. Okay? We have 8, -20, and 12. Well, in terms of the numerical coefficients, we can factor out a what? I think 4. And what about the variables? A, b to the what? B to the 3rd. We want the smallest exponent. So let's take out the 4ab to the 3rd. And we're left with the first term. We have 2ab minus 5a squared. The b's will cancel. Plus, taking out a 4. So that's a 3. A's will cancel and the b's will cancel. So that's it, plus 3. Okay, so we factor that. Now look at this next one. Look at what we have here. We have x times x minus 1 minus 13 times x minus 1. Look at it very carefully. Both of these expressions have a common factor. Look at this. For this one, x is a factor and y plus 1 is a factor. For this one, 13 is a factor and y minus 1. I said y plus. Y minus 1 is a factor. Both of them have a y minus 1 as a factor. Okay? So what that means, y minus 1 is the GCF. It's common to both of them. So it is the GCF. So we can factor it out just like we did before. So if we factor out a y minus 1, what's left after we take that away? I shouldn't say take it away, but after we divide it out. What's left, and you have to put it in parentheses, is x minus 13. That's what's left. Because basically you're saying when you have this, when you factor out the negative y, the y minus 1, what you're basically doing is dividing by y minus 1. And if you divide by y minus 1, what's left is an x. And that's where the x comes from, right here. Okay? When you divide 13 over y times y minus 1 by y minus 1, you're left with 13. And so that's where this 13 comes from. So what we have is kind of an expanded example of extended example of what we've been doing, but you have to be able to recognize that that y minus 1 is a GCF. So another example of the same thing, look at this next example here. 8 times y minus 2 plus x times y minus 2. If you read it out loud, you'll hear what they have in common. They both have a y minus 2 in common, so that's the GCF. Factor it out, and you're left with an 8 plus x. And now you have a factor times a factor, which means you have just factored that polynomial. Here's another one. With this one, though, we have 7x y cubed times p plus q minus p plus q. Okay? Now, what you don't see is a coefficient over here in front of the second p plus q. You don't see a coefficient there. So what you may want to do while you're in the midst of solving your factoring, you may want to place a 1 there, okay? Because anything can be multiplied by 1, but it's important that you understand. If you don't place it there, it's okay, but you need to know that a 1 exists right there. What happens when you look at them? What's common is p plus q. And what you're left with after you factor that p plus q out is 7x y to the third minus what? Minus that 1. You have to remember that 1 is there. So if you want to put the 1 in a case like that in front, you can do that to help yourself remember that it's there. Okay, so now it's factored because we have one expression times another expression. So there it's factored. Okay, now look at the next one. What do they have in common? Each term has a 2m plus n. So let's factor it out. Once we factor it out, we have 5x squared y cubed minus 2. Okay? The 5x squared minus y cubed comes here, and then the 2 comes here. And now it's factored. Now, to factor by grouping, we're going to be talking about this extensively, I think, in section 6.3 or 6.4, one of them. I can't remember exactly, but factoring by grouping is used when you have 4 terms. Sometimes you'll be given a 4-term polynomial, and you'll be asked to factor it. If none of the terms can be combined to make 3 terms or 2 terms, then you have to consider factoring by grouping. When you have 4 terms that can't be combined any kind of way, always try to factor by grouping. And what factoring by grouping does is allows you to create 2 binomials which can then be factored. Watch what I'm talking about. Watch and listen. Look at this first polynomial, ab plus 4a plus 7b plus 28. Now, look at the first 2 terms, ab and 4a. Do they have a common factor? Do they have anything in common? ab and 4a. They do. They have an a in common. All right? Look at the second 2 terms, 7b and 28. Do they have something in common? A factor in common? Yes, they both have a 7 as a factor. Now watch what I do here. If I put ab plus 4a in parentheses, and I put 7b plus 28 in parentheses, I haven't changed anything about the problem by adding those parentheses. But what I've done is created 2 binomials that I can now factor the same way we've been factoring. So watch what I do here. Looking at the first binomial, right here, ab plus 4a, can't I factor out an a from that? If I factor out an a, what it leaves me with is b plus 4. I factored away the a. Plus, now if I look at the second binomial and factor out a 7 that we say they have in common, what does that leave us inside? If we factor out the 7, we have a b plus 4. But notice now, they both have a b plus 4, which takes us right back to the problems we just did on the previous slide. Now we can factor out what's common to the two of them. They both have a b plus 4. Factor it out. Once you take out the b plus 4, you're left with a plus 7. And here we have just factored by grouping. We grouped two terms together based on those two terms having a common factor. Let's look at another one. xy plus 3y plus 4x plus 12. Well, the way they're situated here, we can factor them the way they are. I can group them the way they are. It's 4 terms. You only use grouping when you have 4 terms. So we could go ahead and group them the way they are. I can group xy plus 3y plus 4x plus 12 because xy and 3y have a y in common and 4x and 12 have a 4 in common. Then I can factor out from the first one, I can factor out the y, and it leaves me x plus 3. The second one, I can factor out the what? 4, and it leaves me x plus 3. Then they both have an x plus 3 in common. In fact, that's what we look for when we're factoring by grouping. We want them both to have some kind of common binomial. Okay, so we have x plus 3 that we can now factor out, and it leaves us y plus 4, and we've just factored. The cool thing about factoring by grouping, though, is many times you can rearrange the terms in a different order, and sometimes you have to rearrange them in order for factoring by grouping to work. But let's look at the same terms and try to rearrange them so we can factor them a different way. So I'm going to do the same terms, but I'm going to rearrange the order. For instance, if I have xy, and I put the 4x with the xy, and I put the 3y with the 12. Don't the first two terms still have something in common? Yeah, the first two terms, now they have an x in common. The second two terms, the third and the fourth terms, have a 3 in common now. So I can group them according to same terms. I've just rearranged them. Now I can group them with parentheses so I can factor out an x, which will leave me y plus 4, and I can factor out a 3, which will leave me y plus 4. But now they both have a y plus 4. So I can factor out y plus 4, and I'm left with x plus 3. But look at the two finished products that we have. They're the same. They're exactly the same. Y plus 3 times y plus 4 is the same as y plus 4 times y plus 3. The commutative property says the order in which we have those factors doesn't change the product. So many times you can group them different ways and still you have to come up with the same answer. Sometimes you will try to group it one way and it won't come out right. You won't be able to factor it. But if you rearrange it, you will be able to factor it most of the time. So we're going to factor by grouping. The steps are there. You can group the terms into two groups of 2 terms so that each group has a common factor. Factor out the GCF from each group. If there is now a common binomial factor in the groups, factor it out. If there is not one, then you have to rearrange the terms and try again. Okay, so let's see what happens with this one. 40x cubed minus 24x squared plus 15x minus 9. Well, the way it is, excuse me, I say we can group them the way they are. 40x to the third minus 24x squared, because I'm looking and seeing an 8 as a factor there and an x squared, plus 15x minus 9. So I'm going to group them the way they are and see if we can go ahead on and complete the grouping, factoring by grouping. So in the first binomial, we can factor out an 8. I think that's the biggest, 8, and then x squared. And it leaves us a 5x minus 3. Now, over on the other one, we can factor out a 3, and we'll be left with 5x minus 3. Hey, yay, it worked out the first time. Notice they both have a 5x minus 3. That's what we wanted. That's what we wanted. Okay, so we have now factor out 5x minus 3, and it leaves us an 8x squared plus 3. That is the factored form. Notice it's not factored until you have one thing times another thing. Okay? So let's factor a few more by grouping. Let's look at these. We could looking at it, you may think that there's nothing in common the way they are. So let's rearrange the first set. Let's rearrange it. Let's put the 2xy with the negative 2x. Now remember, you have to take the signs with them. If you're going to rearrange them, they have to take the signs. If it's negative, you have to take the negative sign with it. And then put the 3y squared with a negative 3y. Do you see what I did? I moved the negative 2x. And I put the 3y squared with the 3y. Alright, so now we can we can group them. I'm going to go ahead and put the parentheses here to save some space. And grouping them, we can now factor out a 2x, and we get a y minus 1. Then on the other side, we factor out a 3y, and it leaves us a y minus 1. Okay? And that's what we want. We want to get a common factor binomial in common, right? So then we take out, oh shucks, we take out the y minus 1 as a factor, and we're left with 2x plus 3y. All right, let's look at another one. 7a cubed plus 5a squared plus 7a plus 5. Now you might look at the first two terms and say, well, they both have an a squared in common. But if you group them that way, then the 7a and the 5 over on the right side, they won't have anything in common. So let's rearrange them. Let's put the 7a cubed with the 7a. And let's put the 5a squared with the 5. And then I'm going to group it The signs in this case don't matter because they are all positive. So we can factor out a 7a, and it leaves us a squared plus 1. And here we can factor out a 5, and we have a squared plus 1. So they both have an a squared plus 1 in common. So we factor that out. And we are left with 7a plus 5. Okay? Now, this next one, if you keep them in the order they're in, then you won't be able to group them. But if you rewrite it and put the 3xy with the negative 3x and the 2 with a negative 2y, I don't know. Let's see what happens. I'm thinking I might want to write it like this. Watch this. 3xy minus 3x. I'm going to put minus 2y because I want to put those y's kind of in the same position and put the 2 right here. Stop it and pause it and look at what I did. All I did was rearrange it again. Okay, so then what happens? We can group. Now I'm going to bring it over some. We can group 3xy minus 3x and the negative 2y plus 2. But the thing is, the negative 2y, you have to keep the negative sign with the 2y. Notice what I did. I put the 2y, negative 2y inside the parentheses, but I put the negative sign with it. Okay? So that meant I have to put a plus sign in between these two expressions. Okay? I have to keep the negative sign with the term that it goes with. Okay, watch what happens though when we factor each binomial out. With this first one, we can factor out a 3x. And you see where it leaves us a y minus 1? Well, ultimately, I want to get a y minus 1 out of this thing that I just underlined in blue. I want to get a y minus 1 some kind of way out of that. But if I factor out a 2, look at it. If I factor out a positive 2, I'm going to get a negative y plus 1. See, if I factor out a 2 from here, that's going to give me a negative y. If I factor out a 2 from here, that's going to give me a positive 1 because the signs are negative for 2y and positive for 2. I don't want a negative y and a positive 1. I want a positive y like this and a negative 1. So what I need to do is factor out a negative 1, and that's going to change the sign. I'm sorry, negative 2. Negative 2, and then that makes my y positive and my 2 negative, which is going to make it a negative 1. If you have to stop and look at it, pause the tape. I'm going to do 1 or 2 more like this. But we have to factor out a negative in order for it to work. Okay? So we have y minus 1 common, and it leaves us 3x minus 2. And so we have then factored it. Okay? If you don't get it, and if I don't have another example here, I will go over this type in class. I think one of the next ones will be similar. Okay, so we have 4xy plus 15 minus 12x minus 5y. Let's try to Let's try to rearrange it. Let's see what happens. Because the way they are, you can't group them. Let's see. If we put the 4xy with negative 12x and the negative 5y plus 15. After you've done a few of these, you'll understand why I grouped it the way I did. Okay, look at it. So now we can go ahead on and put this here. I'm not going to have the room to do it like that. So I need to go ahead on and rewrite it. Let's group them. Four xy minus 12x plus negative 5y plus 15. Remember, the negative sign has to go with the 5y. So when you see that negative like that in front of the 5y right here, you should already be thinking, I'm going to have to factor out a negative number. You should already be thinking that. Now let's see what we get. 4xy minus 12x have a 4x in common. Factor out the 4x, you have y minus 3. So I'm looking for a y minus 3 on the other side. So if I factor out a 5, I'm not going to get a y minus 3. I'm going to get a negative y plus 3. I don't want that. I want to take out the negative 5, change the sign of that to positive y, change the sign of that to negative 3, which is what we wanted. Okay? Then we can factor out y minus 3. And it leaves us 4x minus 5. That's factored. Now let's try the next one. Let's leave it the way it is and try to group it. Now y minus 18 plus y cubed minus 4y squared. Let's factor out what? A 9 here, and it leaves us y minus 2. We can factor out a y squared, and it leaves us a what? A y minus 4. That's not helping me any, because I have a y minus 2 here and a y minus 4 there. That's not what we need. So that arrangement won't work. So let's see if we can rearrange them. And do it in a different color. Let's see if we can go 9y plus y cubed minus 4y squared minus 18. Let's see if we can group them that way. I'm trying to group them to see if I'm going to get something that has a common factor. Dagnabbit. All right, let's see what we get. Let's see, can we factor out a y, and it gives us 9 plus y squared. What can we factor out over here? If we factor out a 2 or negative 2, even if we factor out a negative 2, that's going to leave us 2y squared plus 9. Well, that's not the same thing. Well, let's see if we can rearrange it a different kind of way. Let's try 9y minus 4y squared. Let's see, plus y cubed minus 18. I get the feeling this is not going to work. So what if I group it like this? The first two only have a y in common. So it leaves us 9 minus 4y. Oh, this is not going to work. The other one has nothing in common. So guess what? This particular expression cannot be factored by grouping. And I gave it to you on purpose. It can't be factored by grouping. So that's what you have to say. If you run across one that if you rearrange it several times and you still can't factor it, then you have to say it cannot be factored by grouping. Don't say it can't be factored. Say it cannot be factored by grouping. So look at these next two. These will be the last ones. Now what I haven't been emphasizing is, probably because I knew there wasn't one in those particular examples, but I have not been emphasizing to you that you have to first factor out a GCF if the polynomial has a GCF. Look at these four terms. These four terms have a GCF. They have a GCF of 3. Okay, they all have a factor of 3. They don't all have A's, they don't have Y's, and they don't all have X's, but they all have a factor of 3, which can be factored out. And if we would do that, we have 3 times xy minus ay minus 2ax plus 2a squared. All we did was factor out a 3. Now, once we do that, then we can treat the 4-term polynomial the way we have been. But remember, the 3 is kind of going to follow us all the way to the end. Don't forget that. So now we have to group. I'm going to write this in blue. We're going to write these as xy minus ay and group them, plus negative 2ax plus 2a squared. Remember, the 3 is going to be waiting for us at the end. So I'm going to factor out a y here, and it's going to leave us x minus a. And I'm going to factor out a negative 2 over here. No, not a negative 2, a negative 2a. And we're going to be left with x minus a, because I factored out a negative 2. And this thing right here is a y. It doesn't look like a y. All right, so now we have left over our 3. But what do we have now? We have x minus a times y minus 2a. So ultimately our answer is 3 times x minus a times y minus 2a. So we have three different factors here, but you cannot forget to bring down a 3. Okay, so in the next one, the GCF, all of the terms have a 5 that's common. So we have 5 times 3xz plus 3yz minus xy minus y squared. So now we can group them. We can have our, remember, our 5 is going to join us all the way at the end of the factoring. The 5 is going to join us down here. So what do? We group 3xz plus 3yz plus negative xy minus y squared. Okay, so let's see. We have now, we can factor out a 3z, and it leaves us x plus y. And over here we can factor out a negative y, and it would leave us x plus y. So at the very end we have 5 times all of this. X plus y is the common factor, comes out 3z minus y. And there you have it. We have just factored by grouping.